In lesson 3, we're going to do our first set of proofs with parallelograms. So our first one says ABCD is a parallelogram and DF is congruent to BG. They want us to prove that triangle DEF is congruent to triangle BEG. So we're going to work with little triangle on the top and little triangle on the bottom. So as we go through this here, we'll start with our givens. So our first one says ABCD is a parallelogram. And then they also give us that DF is congruent to BG. So they give us one nice and early that shows that our two shapes are, or that our two triangles are congruent. We've got a side there. So now we got to work with some of our other features. Now, there's a couple of different ways we could go about this in order to try to get as much stuff accomplished in one step. I'm going to say this next. DC is parallel to AB. And the reason that's true is because opposite sides in a parallelogram are parallel. So now once we say that, I can put my arrows on there. Now I can talk about a couple of different things. I can talk about my set of alternate interior angles there at 1 and 2, as well as 3 and 4. So by choosing that as my next step, I can get a 2-for-1 with both sets of alternate interior angles. So angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Parallel lines form congruent alternate interior angles. And now I have enough information to finish this off because triangle DEF is congruent to triangle BEG. And our pattern here, we have angle side angle and angle side angle. So that's a nice quick way. The other way you could have done this is you needed the parallel piece to get one of those sets of alternate interiors, and then you could have taken your vertical angles here, and then you would have angle, angle, side. Now the problem is DB is a diagonal, but FG is not. Therefore, in this proof, you cannot say that the diagonals bisect each other because FG is not technically a diagonal. A quadrilateral must be a parallelogram if one pair of opposite sides is. Well, every time we talk about one pair of opposite sides, we need both of those. If we get one set congruent only, well, that doesn't really help us. That doesn't really show that we have anything. Parallel only one set gives us a trapezoid. And parallel and the other pair of sides congruent is an isosceles trapezoid. So this right here gives us nothing. Parallel only gives us a trapezoid, and parallel and the other ones congruent is an isosceles trapezoid. So it says for you to explain your choice, and you can write down in basically what we just wrote next to each answer choice, but all other answer choices can provide a different shape. The only one that is going to have one pair of opposite sides and make a parallelogram has got to be congruent and parallel.